Welcome to Study Loop.
Our question says that a baseball is hit with the speed of 27 meters per second at an angle of 45 degrees. It lands on a flat roof of 13 meters tall nearby building. If the ball was hit when it was 1 meter above the ground, what horizontal distance does it travel before it lands on the building? Well, to get distance traveled, we need velocity times time. We'll know the velocity in the x direction, right? Because the velocity in the x direction is going to be v naught cosine theta. And so we need to find the time. So I wrote down what we were given here. We're given v naught, we're given theta, we're given the height of the building, y is 13 meters, and we're told that you start 1 meter off the ground. So using that, we could probably solve for t because we have an equation that has all these values in it. Y is equal to y naught plus v of y times the time plus 1/2 times the acceleration in the y direction times the time squared. Okay, well, let's go ahead and put all of it on one side of the equation and set it equal to 0. We do that, we find that this is equal to minus 1/2 times gravity, the minus 1/2 because gravity acts in the negative direction, times t squared, plus v of y times t, plus y naught minus y. All of that's equal to 0. So now we can use the quadratic formula to solve for t. Since we have t in multiple parts of the equation. So t is going to be equal to minus v naught, or v of y, using quadratic formula, plus or minus the square root of v of y squared, minus 4 times minus g over 2 from the 1/2 g. It's just g over 2. Let's make that a little more legible. Minus g over 2 times y naught minus y. Okay. Make that look more like a parenthesis. There we go. Extend the square root to include all that. And all that's going to be divided by 2 times minus g over 2. Okay. Now you plug in the values for v of y, you plug in the value for g, which is 9.8 meters per second, you plug in the value for y naught and y, all labeled above. Well, also here first, I realized that we need to calculate v of y. So first v of y is equal to v naught times the sine of theta. Okay, so 27 meters per second times the sine of 45 degrees, and that's equal to 19.09 meters per second. So now we have everything we need to solve for t. You plug that in, and you'll find you get two values for t because of the plus or minus. You have 0.788 seconds, comma, and then you have a longer time, which is 3.108 seconds. And let's finish writing that out. Okay, so the question then is, which time do we use? Well, the smaller time is the time it takes for the baseball to reach the building's height on the way up, and the larger time is the time the baseball reaches the building height on the way down. We must choose the larger result because the baseball cannot land on the roof on the way up. So we're going to use the larger result for t that we just calculated. And using that larger result, we can now calculate the distance. So distance x is equal to v of x times time, which is equal to v naught cosine theta. And the time we were going to use is the longer one, so 3.108 seconds. Okay, so for v naught, 27 meters per second multiplied by the cosine of 45 degrees, all times 3.108 seconds. And this comes out to be 59.3. And this is meters. So we'll box that in as our solution.